so far we are aware of how to use chain rule using trigonometric functions. Okay, now let's work it on inverse trigonometric functions. They're pretty interesting. Okay, maybe a little tricky. Okay, we'll take one by one at a time and see how it works. Let's talk about the first guy. So y is equal to sine inverse of x. Okay, if I have to differentiate this, that is dy by dx would be 1 by root of 1 minus x squared. Okay, that formula we already know. Right, there's something else which we don't write, that is d by dx of x. Okay, this x comes from here. That's it. Right, so what happens is these two guys will get cancelled and give you 1 by root of 1 minus x squared into 1, which goes like 1 minus x squared. Okay, that's the formula which we already know. Right, so dy by dx would be this much. Cool. Now what we write is a chain of this thing. Right, if you have to use sine inverse of x in chain rule, all right, instead of x, something else. So let's say y is equal to sine inverse of something else, whatever it is, some function. So let me take it as a bracket. So now what happens? It goes like dy by dx would be 1 by root of 1 minus, all right, if there was an x, there's an x squared. So there's a bracket, there's a bracket squared. That's it. Into differentiation of x. Okay, so into d by dx of that particular bracket. And that's it. So that would be my general function. Right, general formula I can say. Now it is more precise in terms of chain rule. Now if at all I say y is equal to sine inverse of, let's say I have e power x here. Okay, so if there's e power x here, there's e power x, there's e power x. Like in, I have x here, there's x here, there's x here. Right, so what happens to this? So dy by dx would be 1 by root of 1 minus, don't write x squared here. Okay, don't do that mistake. So whenever sine inverse comes, you need to assume it to be a bracket squared, into differentiation of that particular thing or bracket or function, whatever it is. So e power x comes here and e power x comes here. Whatever comes inside here should come here and here. So what happens to this? That is 1 by root of 1 minus e power x the whole squared into e power x. That's your answer. Let's do another problem. If all I have y is equal to sine inverse of, let's say, tan x. Okay, so what happens? The 1 by root of 1 minus which squared into d by dx of something. So what is this guy? That is a function basically. What is inside the inverse function? So the tan x comes here. Okay, and the tan x comes here. Don't write only x squared here. Okay, you're not differentiating sine inverse of x. You're differentiating sine inverse of tan x. All right, so if you're differentiating sine inverse of any function, that function comes here. Keep that in mind. All right, let's go ahead. That is 1 by root of 1 minus tan x the whole squared into differentiate this secant squared x, and that's what we have. So you can do whatever number of problems with this chain of sine inverse of x. Let's say I don't have tan here. So there is no tan here, there is no tan here. That's it. Okay, this guy would not be there. Right, so what happens? This is a whole format, this problem. Assume something else. Let's say you have let's say root x here. So what happens? So root x comes here, so root x comes here, so root x and root x. Now how do you get this? This is the differentiation of root x, that is 1 by 2 root x, and that's it. How simple. So you want to write tan x here, cos x here, e power x, log x, whatever you write. So only thing which changes, this would come here and here, and you got to differentiate whatever comes here and puts the answer. Very simple. I hope you get this. Try working the same methodology with the others yourself. If not, you can follow the video later. Okay.